As I said, this is probably the pinnacle of our high school education when it comes to chemistry. This tool is the tool you will use, like when we started with the mole, and we're going to finish kind of today with what we call stoichiometry. You'll be fine.
That's not a word.
Or stoichiometric, depending on where you're from. Then you will be using this constantly. In fact, I'll even say when we started with chemical bonding, that's the stuff that you just gotta have to continue to know constantly. And so if you're struggling in the areas of ionic covalent bonding and naming, making formulas and stuff like that, or in writing and balancing chemical equations, we have to, it doesn't go away. It's just like conversions. Conversions are back. They don't go away. We need to be able to do these things. So you do what you need to do either before school or at lunch to make sure you're doing that. Or interact with AI Lesniak, because AI Lesniak does know the answers, as some of you know. But it doesn't just give answers. Virtually every prompt I've put into this thing has given a huge explanation on how you get to where you go. And so far, I've not found one that is incorrect. I've found a couple that have been like, they're probably not worded perfectly, but they haven't been wrong yet. So we're hoping that this will also be a pretty well done interactive tool. So what are mole conversions? Well, you're gonna find out you can get an airplane to any destination. And the mole, notice where the mole is?
Middle.
The mole is the international airport. It is the place to go, because from there you can get anywhere. And again, today might make sense in when you're hearing it, but it really gets driven home when you actually do them. And so tomorrow, I'll probably try to make some kind of, I will try to make some kind of holiday mole bingo game. I might even have a prize or two.
Should be pretty good if Mr. Leslie
All right,
has
so
one.
here we go.
Never has one.
First of all, mass to mole. So I don't care which one of these little lands. These are all different destinations, these three especially. Now this one down here is actually like a little transfer terminal. Have you noticed the escalator? Who's ever been in an airport
Those were train tracks.
where you actually have to go to a different terminal? Well, that's kind of what this one is. And this will be our new topic today. But I don't care which one. Somebody tell me, which one of these do you want to make mass land?
Top one.
Top. We're going to the top. All right. So the top here is going to be mass land. Now, good old mass land is going to be measured. What is mass measured in? What's the SI unit for mass, first of all? Kilogram. But we don't often use kilograms because kilograms are pretty big. What do we usually use on our balances? Grams. And grams is the main unit that we'll be using. So in other words, what you're learning today is you're going to be able to take moles and you're going to be able to go to mass. Well, it's actually from, and I'm not going to pretend that you guys have studied these notes, because I know we're preparing for your midterm and I told you the mole wasn't on there. But we have a fact already in your notes that will tell us how many grams are in a mole of anything. Can anybody look through their notes right now? And
It's the avocado guide number.
it's not avocado.
Avocado.
Avocadrus.
It's not Avogadro. That's close though. You're on the right track.
12 grams.
20.
That's where the concept comes from.
I love it.
That's for,
6.0.
what is that called? What is the concept called?
Formula mass.
Instead of for molar mass. Very good.
Oh, I was close.
So you were all on the right track. So molar mass is the conversion unit we're going to use that are able to go from moles to mass or mass to moles. And so you are going to hop on the molar mass flight.
Fifty freeze? No way.
I don't want to hop on a molar mass one.
Molar mass air.
I have to draw this.
The good news is, hopefully, here's what I'm going to do. I'm going to refine the Notebook LM to really draw this for you. And it will. All right. So, do you have to draw it? I would probably do it at least once a year attempt, but you are going to get a beautiful graphic organizer for this. So, but this is part of the learning process. So you want to get on the molar mass air, and why? Because in molar mass air, here's what we know. You can find the mass on the periodic table. I'm just going to put that as PT of any compound. And that is equal to 1 mole of that compound. And I'm going to leave those little blank because I don't know what the compound is. Give me a compound in the world. I don't care which one.
H2O.
What is the world covered in?
H2O.
Okay, water. Table salt is actually true. It's not that. What would happen if the oceans evaporated?
There'd be sand.
We'd be covered in salt.
We would
So,
die.
Oliver wasn't that far
Good
off.
one, Elijah.
Yeah,
So,
that's what he was thinking.
in other
when
words-
the world-
Hey, in other words, the mass off the periodic table, you can look that up, is equal to 1 mole. And for any compound, that's why it's blank. So for water, if we look up water, there's 2 hydrogens. Each of those is 1, right off your periodic table. And then there's oxygen, and that one's 16, right off your periodic table. And 2 plus 16 is
18.
all right, so how would I write that? Well, just make sure we know how to write it. It would be I'm just gonna rewrite it here in mass land again, nice and big. So it would be the mass in grams off the periodic table is equal to 1 mole of any substance any substance. We are talking about pure substances here. Pure substance, elements and compounds, is equal to 1 mole of that substance. With that unit equality, we're going to be able to convert grams to moles and moles to grams. You just got to get on the right airplane. And you got to know what to do. It's not hard. But notice, are you going to have to be able to make compounds? Yeah. If you don't know what the compound is, how are you going to look up its molar mass? Answer, you're not gonna. You're going to get it wrong again. But don't do that. We're good chemistry students. All right, now there are other things right in your notes. There's molar mass. What is another one that's right in your notes that you know something about 1 mole?
How 1 mole is basically just a scaled up atomic mass.
The
Yeah, we
atom
got- we
thing
got the
about
mass one already.
AMU and thousands and dozens and dozens.
It's not thousands and thousands and
Billions and
thousands. Okay, we're gonna do.
billions.
All right, we are either gonna do the number, which he's doing, or molar volume. I can't. Well, there are 2 different destinations. Which one do you want to do? I don't care. Flip.
Mine.
All right, we're gonna do the number. There is a number associated with the mole.
Avocado number.
This is Avogadro's number. So,
Avocado number.
if you're going to do the number of something, if you're counting,
Make the box look like Mexico.
I really want
Oh, yeah. Tiny box.
if you're going to the number of something, if you want to count, what is the SI unit for count?
Inches.
It is the mole you better get on Air Avogadro.
Gosh, that's like a $40 flight right there. You don't trust that plane to get off the ground.
Get on Air Avogadro. Why? Because here's what we know. That 6.02
That is different.
times 10 to the 23rd of anything. You could have a mole of dollars. That's a lot of money. Is equal to what? 1 mole of anything. Just like a dozen of anything is still what? It is still 12. That is a simple way to count, at least by dozens. This is a way to count. So in other words, I'm going to write that again, nice and neat right here, and also put in the things that we count in chemistry. All right? So in other words, in order to get to number land over here, the number of somethings, first of all, what would be the somethings we count in chemistry? Oh, pretty easy. We can count atoms. Yes, you can actually count atoms. We could count compounds, what we'll call molecules. Those would be things that are covalently bonded. But we also have formula units. Who remembers what a formula unit is? It is in your notes. These are different things we can count. Who remembers what a formula unit is? Good. It is another name for a salt. So we could count atoms, molecules, or formula units. What else could we count in chemistry? That's probably about it, because that takes care of individual atoms, that takes care of covalently bonded substances, and that takes care of ionically bonded substances. I don't really know what else there is in chemistry that we want to count. And what do we know? 6.02 times 10 to the 23rd of them, any one of these, depending on what the question asks for or gives you, is equal to, well, if you have 6.02 times 10 to the 23rd, how many do you have?
1 mole.
You got 1 mole. Wait, how can that be?
Yeah.
1 mole of atoms is 6.02 times 10 to the 23rd atoms. 1 mole of water molecules is 6.02 times 10 to the 23rd water molecules. 1 mole of table salt is 6.02 times 10 to the 23rd formula units of table salt.
How many dollars is that?
That's
No.
unspeakable. Remember we said it'd take roughly about 3,000 years for you to distribute $1 million to everyone on planet Earth, all 7.5 billion of them, or 8 billion of them, and then you'd have to do that the next day. They'd have to really spend their money very fast because they're getting 1 million tomorrow.
It would like just be worthless. It would.
Yeah.
There would be no point in money anymore.
No, there would not be any point in money. You would be
Like
correct.
the $20 bill would become like a penny.
Not even.
No, like
$1 million.
real.
I'm
$1
getting $1
million
million tomorrow.
would be like $1.
What is 20 bucks? Nothing.
I'm saying like once it all dies down, the amount of money.
It
No,
doesn't
still
die
be
down for
$1
3,000 years.
3,000 years?
3,000 years.
Jesus is coming by then.
Well,
If we have that much money going around, it's over.
it's over.
No, it won't be that different.
Again, it wouldn't be that different. You have to find something else that has value, because that would be
Gold.
But anyway, since
Bottle cap.
we don't need to
That's
talk
all.
about macroeconomics, it's probably a good idea to get back to mole. And so if I'm going to count something, I want to go to number land, then I got to get on Air Avogadro. And the last one is going to be molar volume air. And we do know that on molar volume air, we were given a fact. What was the fact we were given at standard temperature and pressure? That 22.4 liters of any gas at STP is equal to 1 mole of that gas. And again, I'll write that, oh, this is volume land. and this is volume in liters, and it is of a gas. Make sure we understand that. We're not doing volumes of other things, we're doing volumes of gases. Those can be calculated, but not on this simple thing. You need to know some other information for sure. And so this is the volume of any gas at STP. And that is standard temperature and pressure. And that fact is that any gas will have the same volume regardless of its identity. It will have 22.4 liters. It's blank because it can be any gas, and that would be in 1 mole of any gas. Now please notice these are double arrows, which means you can go from volume to mole or mole to volume. If you're in volume land, then you have to get on molar volume air and the return flight to get to the Mole International Airport. Which does mean, I hope you guys realize, that yes, if I was giving you a volume of a gas, like the air inside of a balloon, at standard temperature and pressure, you actually can count the molecules inside that balloon. I know you think that's amazing because it absolutely is.
Yes.
And that means if I give you the volume, let's say of a basketball, and we say it's at standard temperature and pressure, you can actually understand that you can convert that to moles, and you can tell me the mass of that gas inside of that balloon. Yes, that is 100% possible.
Whoa.
Yes.
How can we have something that precise?
How can we have something that precise?
Like, how do we measure the volume so precisely that we can count the number?
Scientific measuring
well,
of
again,
estimation.
This is a good question. Now, I will say this has a lot to do with the behavior of gases that we were able to figure out these facts out, all right? But it has to do because the distances between molecules and gases really is independent of their volume. In other words, they're so interact. We're going to talk about gases in particular. We'll call them ideal gases, that they interacted with each other, that they don't really care who their neighbor is. If they randomly would somehow approach a neighbor and actually have an interaction with them, we assume that those interactions are perfectly elastic. They're perfectly elastic with the side of the container as well. Now, again, there is really no thing that behaves like an ideal gas perfectly, but I'm telling you, the science is very, very close to where you can certainly make these estimations and be somewhat close. Again, we're doing ideal situations here. So is it going to be perfect? But let's say we're not perfect within, let's say we miss, I don't know, let's say we miss 10 million atoms. You would think that's a big mistake. Divide 10 million into that number. It is, percent error is like, it doesn't even, it's still 0. In other words, do we absolutely have to be perfect to get within 99.9999999% of the real truth? The answer is no. We don't have to be absolutely perfect, just as long as they behave somewhat like it. Now, with these interactions though, at standard temperature and pressure, like if you have gases that act these ways, that's its mass. We can do these calculations and go, wow, at least within the degree of our balances that we use, they're right on.
Can you
So-
like write out that number in like full length?
Yeah, I kind of did one time. The
Oh yeah,
zeros
that's
right
right.
off the board.
Oh yeah.
Yeah, I started going. So, all right, there is one little thing here, and so I think you can see here. By the way, I got some talking over here. They're like, "Hey, he's recording this. I'll just talk to Lesniak AI." No, this is the live thing. This is better.
Extremely like.
Volume to mole, yeah, we do that. Mole to number, sure, we can do that. Mass to mole, yeah, we can do that. And that brings us to lecture 9. Ah, lecture 9. Stoichiometry.
I don't know.
Stoic,
You have to ask me.
up to you.
I like this. Makes me feel stoked.
By the way, I did get this new shirt.
Congratulations.
Nerdy.
It may be.
But only periodically.
Wow.
Alright, wow.
I don't get it.
Wow.
You don't get it?
No, I get it.
That's awesome.
Oh,
That's the coolest shirt ever.
really unique, Mr. Lesbian.
Wait, can you say it one more time?
But only
Oh my
periodically.
god.
Oh, I mean, sorry.
Oh, stoichiometry? Thank you. Or stoke. Stoke. We're stoked. Stoichiometry.
No way.
Alright, so here's the good news about stoichiometry.
Joke.
And actually this is the good news about the entire lecture 9. 1, it's going to take literally 5 minutes to do. 2, you learn nothing new.
Hey.
Awesome.
No.
Why are we even doing it?
Why are we doing it? 3, it actually combines all the topics from lectures 8, 9, so 7, 8, and 9.
Why haven't we just done like
So, here is, in fact, I decided this morning, I do a lot of thinking in the shower, I decided this morning that I'm actually reordering all of chemistry next year.
Couldn't you do it this year?
No, you get the same, we get to the same place at the same time, we just would do it differently.
Okay.
So what is this? This is the study of the quantitative or measurable relationships found in a chemical reaction. Do I have to do assigned seats in the 11th?
No!
Then stop talking!
Hey, you can do it in the 11th
10th grade, you're not all 10th graders in here.
I know, I'm literally the other one. I'm the opponent.
You're not from here.
The study of the quantitative, and of course quantitative is a measurable observation.
We already knew that. We studied our notes, right?
I know, you definitely study your minutes every night.
Yeah, for sure.
Hey.
It says example, but we're going to do all our examples tomorrow. Pretend to write. All right, here's the steps you will need to take in order to do a stoichiometric calculation. 1, you have to write and balance a chemical equation. Some of you are already screwed. Don't be so mean, Mr. Lesniak. No, I grade your tests and quizzes.
By the way, look at my midterm. What you did.
I didn't look over your midterm.
I told you not to expect anything.
When are we getting the grades?
Wait, can we have it back tomorrow?
No. You got to remember, not only am I doing
He has
this,
to brace
but I'm
himself.
giving other midterms, and I'm grading papers as well.
It's probably like 2,000.
So my grades are due December 22nd. So that means you will know your midterm grades before Christmas. Merry Christmas.
Uh,
Leslie asked her to come on down our chimney and put it under a tree.
okay, it better be a good grade though. I hope it's a good grade.
Are you gonna eat the cookies
You get the.
when you come back?
Yeah, we'll see. All right. So you have to write and balance a chemical reaction. For those of you struggling in this area, this was, of course, on your midterm, where you actually had to predict products and do that. Oh, wasn't too bad. But for those people, the good news is we get a little bit more time with it. That is good. But also, that means you're going to have to hammer it down. We've got to get it done. Second step, you need to identify the mole ratio. Oh, now we see the mole. The mole ratio is between what is given in the question and what is being asked by the question. So in other words, where do we find that mole ratio? Well, there is a number inside chemical equations that tells you how many of those things you have. And of course, that number, how do you know how many things you have in a chemical equation?
You count them.
Well, no. There's actually a number right there in front of each substance. That number right out in front of each substance
Atomic
is
number.
called the
Coefficient.
coefficient.
Yeah.
So if I do a simple combustion of hydrogen gas, while you guys are writing it, you can write this right underneath. We know that hydrogen Not really combustion on Earth, but it's close. Well, it is combustion. I'll take that back.
We've done it a few times in the past.
Yes, we have one hydrogen. We know that this is not balanced. So what do we need to balance this chemical reaction? Well, we definitely need 2 oxygens. But that gives us our 4 hydrogens. So that means I need a 2 here. This gives us the coefficients. Now, each of them are correctly written, and we know how many of each thing we have for the chemical reaction. 2, and now we'll call them moles. 2 moles of hydrogen are needed to react with 1 mole of oxygen to get 2 moles of water molecules. This is called the mole ratio. And so, if I told you guys that the volume of our very first hydrogen balloon, in fact, this would be our first mole conversion problem. The volume of our very first hydrogen balloon was 1.2 liters. From that information, when we exploded it, right here in the classroom, boom, boom!
Ready that time?
Saw it coming.
Huh?
Your mom's
You almost fell out of your seat.
I will call her back. It's probably my father wanting something. What? But I'll call her back. All right. So, with that being said, thank you for telling me. With that being said, this mole ratio you're going to find out is a powerful thing. So, just like here, we're going to need to know the formulas for gases. Just like here, we're going to need to know the formulas for substances. And just like here, we're going to need to know the formulas. So writing formulas is important. Well, of course, for a mole ratio, we're going to have to not only write formulas, we're going to have to be able to balance chemical equations. And the last thing is convert what you're given into moles.
Oh my god.
Convert what you're given into moles. Now, you might be given moles, and then you don't have to convert it, but convert what you're given into moles. And that will give us to this, I'll call this the mole terminal. Mole transfer terminal. So we're going to have to take the escalator to and back. All right? And so this is the mole
Why did I think those were ladders? I thought it was a
ratio. We'll call it the mole ratio terminal.
I thought they were doing
Now we're going to do ratio. Transfer is a good transportation. Right?
That's such an old
And what does the mole ratio terminal do? Well, it will allow us, using a balanced chemical equation, the mole ratio terminal, using a balanced chemical equation, you can go from blank moles of one substance equal to blank, we don't know those numbers because it has to do with the blank moles of another substance. One substance to another. That is written very poorly. One substance, blank moles of one substance to blank moles of another. And again, you have, I don't know what the blanks are, you have to use your balanced chemical equation. But for this one that we have on the board, let's say we want to, here's how, like you gotta find some pleasure in this. I mean, I don't even care if you don't care about chemistry. If I told you that this is 1.2 liters of oxygen and I blew up, I could actually ask you, how many water molecules, counting them, how many water molecules did we make?
I'd rather go on not knowing.
I would rather make a hydrogen bomb.
How many water molecules were made? Were
I wanna keep
produced?
the magic.
That's a story.
Two moles. You do not have to guess.
I wasn't against.
Hold on. Let's think about it.
Now look, here's what we're going to do. I'm going to walk you through this one thing that we're going to be done for today, but it's going to show you that we're able to do this. And all you have to do is figure out where you are
Done.
and where you have to go.
I'm at
In other
Comfort
words,
Academy. I have to leave this.
Look
room.
at this. I'm at liters of H2O. Sorry, of H2. Sorry. Whew. I'm at liters, so I'm over here in volume land. And I'm in hydrogen gas, H2.
Yeah.
All right, so my given, H2, 1.2 liters. Now, again, we're going to assume this is at STP. This is slightly off STP in here. This is actually room temperature. There is a molar volume for room temperature. I'll give it to you later. We don't need to do that now. It's marginally different, only fractionally different. All right? And so that's where I'm at. But I need to get all the way over to here. I need to know the number of water molecules are made. I gotta go from liters of H2 to the number of water molecules. Oh, well, we know we gotta go to the mole. Plus, are we changing the substance? Answer,
Yes.
yes. If you change a substance, then you better believe you're gonna have to go through this mole ratio terminal to get from 1 mole of one to the other. So, hopefully you can see how we're gonna do this. We're gonna go starting here, we're gonna go to here, and we're gonna hop on our escalator, change substances, back to the mole, and then we're able to take air Avogadro and figure out the numbers of things.
Oh, so the escalators are for changing substance. Okay.
So, let's walk through it. Conversion chart, number 1. Where does your given always go? Top. 1.2 liters of H2. We know that's a gas. We're in molar volume land. That's where we're at.
Prove it.
Well, guys, we already got our unit equality. Now we just have to arrange it properly. How do I arrange this so that liters of H2 cancel and moles of H2 are left? Goes where? It does. There are 22.4 liters of hydrogen gas. Notice I'm keeping my substances in there in 1 mole of hydrogen gas. Now, some people in this classroom who are not paying close attention might go, where did you get that from? Where did you get that from? Look, it's any gas at STP. I just can change this to any, as long as it's a gas, I can change this into any substance.
Are you
It
gonna
is a
change that for?
fact.
Is it liters hydrogen square?
Well, that will get rid of liters of H2. That's good. That leaves us with moles of H2. Once you're in the mole,
Wait, you just wrote 22. It's 22.4.
sorry,
Aha! I knew it.
22.4 liters. We're in the mole.
That would have made a big difference.
Actually, probably wouldn't have. But it would have been wrong.
Of course it would be.
Now I gotta go, oh, no, I gotta get out of H2 and I gotta get into H2O. Well, good, we've got a land that we can do that. So we head down to the mole ratio land. That means we need a balanced chemical equation. We have to identify the given and ask, and then I can be able to do it. The given is H2. The asked is H2O. What are the numbers in front of those two things? 2. It is a 2 to 2 mole ratio. If you put 1 to 1 and reduce, it's not going to change the math at all. But I want you to get in the habit of whatever that coefficient is, write it in. And so in other words, 2 moles of hydrogen is equal to 2 moles of water. 2 moles of hydrogen. Why did I put hydrogen on the bottom?
Because you gotta.
Cancel out.
It has to cancel out. Oh my goodness. Notice we went down the escalator as H2 and we came up the escalator as H2O. So after we went through customs, we got our stamp, and now we're in a new thing.
Oh, we're on the.
Off to Air Avogadro, and we know this fact,
Check.
that there are 6.02 times 10 to the 23rd molecules in 1 mole of water. That we just know. Just like if it were a dozen, there'd be 12. So now I just need to arrange this unit equality properly. So in 1 mole of water, why did I put this on the bottom?
Gotta cancel it out.
Because the moles of H2O have to cancel out. There are 6.02 times 10 to the 23rd molecules of water. This is utterly amazing.
Whoa.
It's amazing.
If I put this into my calculator properly, I will see that it's 1.2 pretty much, just because the way everything fell out, divided by 22.4 times 6.02 times 10 to the 23rd. You will know how many water molecules, when that balloon blew up, hit Sophie in the face and stuck right here.
Does it say of or?
Oh,
Oh my
Water.
goodness, there's still 20 minutes in this class.
Wait,
now,
what?
That's good. Now, I don't have a calculator on my person, but some of you may, and you could easily, what did you get a number?
3.225 E22.
All right, so yeah, I like that. I think that's correct. Say that again, but it's gonna be 2 significant digits. Remember, your given dictates your significant digits.
Yeah.
So
So
3.6,
3.2.
3.2 times 10 to the 22nd?
Yeah, 22.
I think that's good. Can we have someone confirm that?
What?
I confirm it.
When did Charlotte get black?
Did you actually plug it into a calculator, or are you just confirming it because it's Russell? So what you just did is we just counted the water molecules I exploded earlier in the year. That is good work.
Crazy.
That is good work. Yes.
Can I use the bathroom?
Yeah, it's a good time, and we can wrap this up.
Yay!